Let's have a discussion on Coulombs Law. According to this law, if the bodies are charged by similar electrical charge, they will repel each other. If the bodies are charged by opposite electrical charge, they will attract each other. Force is a vector quantity, which means it has direction in addition to its magnitude. Here the force acts along the straight line, joining the centers of the charged bodies. Now, if you increase the charge Q1, keeping Q2 unchanged, the force is obviously increased. If you decrease the charge Q1, keeping Q2 unchanged, the force is obviously decreased. According to Coulomb's law, F is proportional to the product of Q1 and Q2. Now, by keeping their charge fixed at Q1 and Q2, if we bring the charged bodies nearer to each other, the force between them increases. And if we take them away from each other, the force between them decreases. If the distance between their centers is r, it can be proved that force acting on them is inversely proportional to r squared. It is also obvious that this force is not same for every medium. For example, if the bodies are kept in air, the force is different from the force.
Hi students, Kumar here. Now I derive vector form of the expression for force between the 2 point charges by using Coulomb law. Before that, first you select two number of point charges Q1 and Q2. Q2 providing particular amount of force on Q1, at the same time Q1 providing particular amount of force on Q2. First we find out force on charge Q2 due to Q1. First of all, I find about its vector representation. It is represented by F21 vector. It means that force on charge Q2 due to Q1. Its vector representation F21 vector. It is acting along this direction R12 cap direction from charge Q1 to Q2. F21 vector acting along. Next, magnitude of force between the 2 point charges expression already know. Substitute here, then into R12 cap, then we get F21 vector. F21 vector acting along this direction R12 cap direction from charge Q1 to Q2. Unit vector acting along this direction. So R12 cap, it is acting along this direction from charge Q1 to Q2. So it is one of the unit vector. Already you know R12 cap, it is one of the unit vector. It is acting along from charge Q1 to Q2. Its value R12 cap is equal to R12 vector divided by modulus of R12 vector. Already you know formula for R12 cap. Next, R12 vector, particularly we find out position vector of the charge Q1 R1 vector, position vector of the charge Q2 already you know R2 vector. Distance between the 2 point charges represented by R from charge Q1 to Q2. This vector represented by R12 vector. Mathematically, by following this diagram, we find about value for R12 vector. How we find out? R1 vector plus R12 vector is equal to R2 vector. R12 vector is equal to R2 vector minus R1 vector. Mathematically, from the diagram we get value for finally R12 vector. This value substitute in left hand side expression, then we get R12 cap. Similarly, we find out R21 cap by following same method. From R21 cap also we get F12 vector. We follow same method, find out. Just in electrostatics chapter, Coulomb law, its magnitude expression follow here. Next I select two similar charges, like charges. Here I selected one is positive, another one is positive. Between the like charges, electrostatic repulsive force is formed there, already you know. Next I select also like charges, negative. So between the like charges, repulsive force is formed there, already you know. Next I select unlike charges, one is positive, another one is negative. So dissimilar charges here I selected. So attractive force is formed between them, already you know. the magnitude of either repulsive force or attractive force F depends on which factor we can be determined by using Coulomb law. By using Coulomb law, we can be determine repulsive force or attractive force, its magnitude value we can be determined by using Coulomb law. So here I select statement for Coulomb law. Magnitude of electrostatic repulsive force between the 2 point charges is directly proportional to the product of charges and inversely proportional to the square of distance between them. Here I select two number of point charges, Q1 and Q2, both they are like charges. Distance between the 2 point charges represented by R. Which force is formed between them? Electrostatic repulsive force is formed between them. So the magnitude of F electrostatic repulsive force between the like charges, F value depends on which factor? F directly proportional to Q1, Q2 and F inversely proportional to R square. Combine both expression, we get Coulomb law expression. F directly proportional to Q1, Q2, F inversely proportional to R square. Cancel the proportional symbol. Next I substitute a constant K. F is equal to K into Q1, Q2 divided by R square. Next the value for K. Substitute here 1 divided by 4 pi epsilon naught into Q1 Q2 divided by R square. So this one is also magnitude of repulsive force between the two number of like charges. Epsilon, what about epsilon naught? Epsilon naught is the permittivity of the vacuum or air. Epsilon naught value 8.854 into 10 power minus 12 coulomb square, Newton power minus 1 meter power minus 2. So epsilon naught value substitute here, then we get K value 1 divided by 4 pi epsilon naught. Epsilon naught value substitute here, then we get K value 9 into 10 power plus 9 Newton meter square Coulomb power minus 2. Here we get K value proportionality constant value for free space condition only. Here we get proportionality constant K value. Here we get next already you know relative permittivity, it is equal to permittivity of the medium divided by permittivity of the vacuum. It means that what about this expression? Epsilon R is equal to epsilon m divided by epsilon naught. Epsilon m divided by epsilon naught. Then you find out epsilon m only. Epsilon m is equal to epsilon naught into epsilon r. The product of epsilon naught into epsilon r, then we get epsilon m. For free space condition, epsilon r value 1, then epsilon naught replaced by epsilon m, then we get a k value, same value. Here we get same value. Next, the direction of this force is along the line joining of the 2 point charges. The direction of this force is along the line joining the 2 point charges. You follow the figure, we get the direction of repulsive force.